Welcome to another one of my SAT mathematics videos. This is about coordinate geometry and functions. When I say functions, it's really just transformations of functions, because that is the only mildly difficult bit, I'd assume, in what the SAT expects of you to know, in the chapter of functions. Regardless, let's start with coordinate geometry. So just a quick note, this is how you number the quadrants. That's the first quadrant, that's the second quadrant, that's the third quadrant, that's the fourth quadrant. So you're going anti-clockwise, and in the first quadrant both x and y are positive. Positive x-axis, positive y-axis. Second, x is negative but y is positive. Third, x is negative and y is negative. Fourth, x is positive and y is negative, right? Given that, most linear equations will come in the form y is equal to mx plus c, or they will look something like that. M is the gradient, so in this case 4 is the gradient. It means that the y values will increase by 4 for every time the x value increases by 1. That's what the gradient is. It is how much the line is rising for the time it is running. And c is nothing but the y-intercept, which is 5 in this thing. It just states where on the y-axis does it cross it. So this means it crosses the y-axis when at y equal to 5. So sometimes you might see an equation like this, and they might ask you to find the gradient of the y-intercept. The process is to first isolate the y value and its coefficient. So we'll move 8x to the other side and 7 to the other side, so we end up with this. Then we divide everything by 3 to isolate just y. Once we have this, we see it is in the form y is equal to mx plus c. Here c is a negative number, which is minus 7 by 3, and the gradient is 8 by 3, and therefore we have solved the question. If two lines have the same gradient, they are parallel. If two lines are perpendicular, the product of their gradients is minus 1. So the lines y equal to 4x plus 5 and y equal to minus 1 by 4x plus 3 are parallel, because 4 into minus 1 by 4, which are the gradients, equals minus 1. I'm going over this really quickly because I'm pretty sure most of you, in fact all of you, know this. If you do have questions, however, I just leave a comment and I will get back to you. When you have to find the distance between 2 points on 2 points, the formula is y2 minus y1 the whole square plus x2 minus x1 the whole square is equal to d square. So let's assume our 2 points are 5, 8 and 2, 3. So why this thing works is we can see that we can draw a right angle triangle with this being the hypotenuse. This side over here, or the altitude, is nothing but y2 minus y1 in length. In other words, it's 5 units in length, while this is nothing but x2 minus x1 in length. That's 3. Therefore, the line over here, the length of the line, or the distance between these, the distance between these 2 points is nothing but the length of this line. Given that this is a right angle triangle, this means that the length of the line is equal to 3 square plus 5 square. The length of the line squared is equal to 3 square plus 5 square. This means that the length of this line squared was equal to y2 minus y1 the whole squared and x2 minus x1 the whole squared, and that's why this formula works. That's how you do it. So you can just square root that to find out. So the square root of 9 plus 25, so the square root of 34 was the answer. If you have to find the midpoint between 2 points, you just get the average of the x values and the y values and create a new coordinate. So let's go back to 5, 8 and 2, 3. The average of 5 and 2 is 3.5. The average of 8 and 3 is 5.5. So the midpoint is 3.5 comma 5.5. Now I chose to state it this way because I think it might tie into some of the older concepts we've put in these videos, and it might be an easier way to think of it. If it is not, the actual formula is x1 plus x2 by 2 is the new x coordinate, and y1 plus y2 by 2 is the new coordinate. Just using the word average puts it in words rather than numbers and letters. Even the words are made out of letters, so I guess dodgy. Right, yeah, but it's the x coordinate is just the average of the old x values, and the y coordinate is the average of the old y values, right? moving on, something we also might be asked to do is find the gradient of a line between 2 points. The solution for the gradient is how much it is rising, so y2 minus y1 by x2 minus x1. So with the same old coordinates, it is rising by 8 minus 3, 5. It is running by 5 minus 2, 3. Therefore, the gradient is 5 by 3. Note that sometimes the gradient may be downward sloping, in which case it is falling. So in this case, if let's say it was 2, 8, and if it was running down, your y2 minus y1 would yield a negative value, because and therefore gradient would be minus. Just try it out with a sample question. So sometimes they might ask you to find the equation of a line between 2 points. At that point, we proceed with the whole finding the gradient as we did in the last case, but this time we did not just stop here. There is another step. So we know that the equation of a line is y is equal to mx plus c. So what we do is we substitute a 5 by 3 into mx. Now we had 5, 8 as a point on the line. So we have one value of x and one value of y. We substitute that. We rearrange the equation to get c, which is minus 1 by 3. Once we have that, we can write the final equation. Y is equal to, substitute the value for m, which is 5 by 3, 5 by 3x, and substitute the value for plus c, which is minus 1 by 3. So that's minus 1 by 3, and that is our solution, right? That is the equation of the line. Another thing that I want you to know about is, and the SAT wants you to know about, is that the equation of a circle is x minus a the whole square plus y minus b the whole square is equal to r square. Now the points a, b is the center of the circle, and r is nothing but the radius. So just that being said, I want you to remember that if the equation is in the form x minus 3 square plus y minus 4 square is equal to r square, that means the center is 3, 4. But if it is x plus 3 square the whole square plus y minus 4 the whole square, the fact that this is that it is plus 3 means that the center of the circle is then minus 3, 4, right? So if this value is positive, then a is actually negative. So same goes for b. So if this is a positive sign, that means the actual value for b or the center is negative. So just keep that in mind when you're solving questions. And when we look at functions, as I said, we'd only be looking at transformation. Now if you have a normal function and if you add like 3 outside the brackets, right, it will move 3 units up. If you have a minus, it will move 3 units down. If it is inside the brackets, now what I mean by this is, if fx is x, right, that if fx is x square, for example, that is a on the outside, as in this. So this would move the x square graph 3 units up. If this changed to that, it would move it 3 units down, right? But if the graph was inside, if the number was inside like this would mean it would move 2 units to the right, and if it was a plus, it would move 2 units to the left, right? So that's what this means. So if we are placing x minus a in the locations where it was x before, that means we are moving it right or left. If the number we are placing a is outside of it and just an addition, then it's moving up or down, right? Similarly, if we do something like this, it would divide all the x values in the graph by 2. But if we had an x outside, so note that this meant 4x square, while this means 2x square, so there is a difference. If this was the case, the 2 was outside the bracket and not with the x, it would mean that all the y coordinates of the graph would be multiplied by 2, right? Similarly, if this is the case, it would reflect across the y-axis, right? If this was the case, it would reflect across the x-axis, because note how this is the graph for minus of x square, while this remains as x squared, and therefore you can see that even if you reflect the parabola of x squared over the y-axis, which is by adding a minus inside the bracket, it still reflects to be a normal parabola, which is x squared as we would predict. But if we had it outside, this would mean minus x squared, which would mean be reflected over the x-axis, just as this would predict over here. I do recommend you do questions if that was not very clear. Those are just formula things. I recommend you kind of screenshot it and memorize it and look at how it's applied practically with the help of questions. Now, in terms of square root function, this is just something I wanted to talk about. So I think it's important that we actually need to understand what a function is. So a function is something that will pass the vertical line test, which means it will only, if I draw a vertical line, it will not cut the graph more than once. That's why a circle is not a function, because if I draw a vertical line, it's cutting it at this point and at this point. It is not a function. But this green line over here is a function, because if I draw a vertical line through it at any point, it will only cut through it once, right? And therefore it is a function. In other words, what a function is if you put an input value, you should only get one possible output value, right? You can have a one-to-one function, means one input yields one output. Many different kinds of inputs can yield one output, but one input can never yield many outputs, right? And so something that happens with the square root function is the root of x will yield one positive number and one negative number. So normally we would expect the square root function to kind of go like this, kind of like a sidewards facing parabola, but that would violate the vertical line test, because then it would cut over here and somewhere down here as well. So therefore when we talk about the square root function, we only assume that we take it as that all the output values are positive and that the function yields no negative values, and therefore the classical square root function graph looks something like this. It ignores the negative bit. And what this does is it has another another reason why the square root function is important to just keep in mind is because the square root function is one of the examples where some values of domain some values of x cannot be a part of the domain. So in an x squared graph, you can have any value of x, minus 99 all the way to 941 and beyond, right? So any value of x and you can take any value of x and x squared will still be a function. But for root x, that is not the case, because if you take a negative value, you're going to get an imaginary number, and that does not work. Therefore, for these values, the domain is restricted. The domain for root of x means that the domain for root of x includes only numbers that are greater than or equal to 0. Similarly, the root of x minus 5 would only include numbers that are greater than or equal to 5, right? And this is very important, because they might ask you which values the domain can take and which values it cannot. At that point, you need to identify the values which the domain can take, which means the x values that can be input into the function. The range is the y values that are output. So I think that's really all I wanted to cover. It is mainly theory, because I believe there are plenty of questions, plenty of resources for this, and right, that being said, in the next video we're going to look at sequences and probability. So they're quite different things, but they're all covered in a very plain way in the SAT, so as in there is not much to it. Therefore I think we can cover both of them in one video, even though they're like almost entirely different. And with that, thank you guys, do have a great day.